So permutations and combinations are the number of ways you can arrange some items. So a permutation specifically is all of the possible arrangements of a collection of things where the order is important. Make sure you leave some space because I need you to add in a vocab word underneath. I don't think this is on your sheet. Fundamental counting principle, but we need to add it in somewhere. So permutation is where the order is important. I'll give some examples once you guys are done copying. We will need our calculators today. Now the fundamental counting principle is the number of possible arrangements of n items is going to be n factorial. Now permutation is going to be when you're just selecting a few items, like 3 out of 10 or 5 out of 20 items. The fundamental counting principle is going to be the number of possible arrangements of all of the items if you're going to select all of them and then put them in order. And it is n factorial, so it looks like an exclamation point, it is, but it is called n factorial. Now n factorial is a mathematical operation for multiplying that number by every integer that is smaller than it until you get to 1. So for example, 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. There is a button on our calculator so that we don't have to type them all out every time. But that's what a factorial does, is it multiplies by every number that is, every integer that is smaller than it until you get to 1. All right, now my example for the permutation is, let's say that I put all of your names in a hat. Let's just say there's 20 of you in here, but I don't think there are. I'm going to select 3 of you. Now, if it's a permutation, the first person is going to get something different than the second person. So let's say the first person I pick out of the hat, I'm going to give $5,000 to. The second person I pick out of the hat, I'm only going to give $1,000 to. And then the third person will get $100. Okay? So the order in which you're selected matters. If you get picked first, you get a lot more money than if you get picked third. Why this is so important is when we get to the back of the notes, we're going to learn about combinations, which are basically the same thing, but the order won't matter. So an example of a combination, just to compare, would be putting all your names in a hat, picking 3 of you. Those 3 people get 10 bonus points. Okay, the order in which you get picked doesn't matter because you would get 10 bonus points whether you're first or third. But the permutation would matter if the first person gets, again, like $1,000. The second person gets, let's say, 500, and the third person gets 100. So a permutation would be if you're getting the order in which you're selected matters. Okay. Fundamental counting principle is when you are going to, if I were to select all 20 people, okay, not just 3 of the people. All right, so in how many orders can 6 people line up from left to right for a group photo? So we have 6 people. All of them are going to be in the photo. So this is telling me that I'm going to use my fundamental counting principle. And some people like to think through these logically. Like how many if you have 6 spots. If you have 6 people to choose from to put in the first spot, I have 6 people that I could put there. Once you put 1 person there, how many do you have left to choose from? 5. Once you put 1 person there, you only have 4 people left for this spot, and then 3, and then 2, and then 1. Okay, so that is the fundamental counting principle, which would be the same thing as 6 factorial. Now, you either need to type this in your calculator, or let's go ahead and find the factorial key on our calculators. And I'll probably put this in our notes up here. We press the math button, arrow to probability, 4. So if you want to add that to your notes, it's the math button. Arrow over to the probability column, which says PRB for probability, and then you'll choose option 4, which you'll see the factorial. And this is obviously beneficial if I were to ask you what 20 factorial was. You wouldn't want to have to sit there and type 20 times 19 times 18 all the way down. All right, so we would, now you do have to type the number in first. You have to type 6 first, then press the math key, arrow over to probability, which you can actually hit the back arrow, and it'll take you there faster than arrowing all the way over. And then option 4, you do have to hit enter, and we will get 720 ways. Okay, the next one, and how many ways can you arrange 10 trophies on a shelf? So you are arranging all 10. We're not just selecting 3 of them. We're doing all 10, which would be the same thing, 10 times 9 times 8, etc., or 10 factorial. So type in 10 first, math, arrow to probability, option 4. We get a very big number, 3,628,800 ways that we can order the trophies. Alright, now the permutations, as I gave the example for permutations, was selecting 3 of you out of 20 and the first person gets a higher prize than the second person. There's a formula to calculate the number of ways I can select you for those problems. The notation will be NPR. These are subscripts. They will be numbers. So you could see for my example above, it would be 20P3. So the first number, the N, is going to be the total number of people, items, whatever that you're selecting from. R is the number that are being chosen from the group, so that would be 3. And then you would substitute into this formula, which you don't have to memorize, but you do have to know how to plug into and apply, which is n factorial over the quantity n minus r factorial. And it does tell us that r has to be between 0 and n. And here's an example, 10p4, 10 factorial over 10 minus 4 factorial. You do your order of operations, which are exponents, and then you would actually perform 10 factorial and 6 factorial and divide them. And I will show you a shortcut that you can simplify those as well. All right, so number 3, 10 yachts enter a race. So that would be the total number, which is our variable n. First, second, and third places will be given to the 3 fastest yachts. So because they tell you that, first of all, it's a race, and they're giving awards to the fastest, you're going to get a first, a second, a third. The order matters in which you're selected. So we're choosing 3. So R would be 3. How many arrangements of first, second, and third places are possible when there are 10 yachts? So for this one, we would be doing 10 P3. We use the formula above to practice, and then the next one I'll show your calculator problems. So this is n factorial over the quantity n minus r factorial. So 10 factorial over 10 minus 3 factorial. Now, to save yourself some time, you can actually expand these, and I think there is one either on your study guide or your homework or something, that if you type the top number in, it's like, I don't know, 700 factorial, your calculator will give you an error because it's such a big number, it won't actually perform it. So in the event that that would occur, you can actually slightly expand these so that you can divide things out. So the top would be, 10 times 9 times 8 times, and I could write 7 all the way down to 1. Or I could stop at 7 and put 7 factorial, right? Because that would be 7 times 6 times 5. And then leave the denominator 7 factorial, and then you can divide out 7 times 6 all the way down to 1 would cancel out with 7 times 6 all the way down to 1. And then we just have to multiply those two together, which should be 72 times 10, 720 ways. Now if you don't like that, you can, for this problem, since the numbers aren't big, do 10 factorial, do 7 factorial. You cannot divide 10 by 7 and then take the factorial. You have to take each one first. Okay. Now, how many 4-letter codes can be made, and make sure you realize that if you see codes or passwords, that you realize that the order matters. Because once we get to the back, we're going to mix up the combination permutation problems, and you have to think, which one am I using? So if you see anything with a password, like if your password was cat, C-A-T, and you wrote TAC, your computer's not going to let you in, right? So the order in which you type it in matters. So for this one, you have to think a little bit. We're doing letters, so how many total possible letters do we have to choose from? Garrett? 26. And we're choosing 4. None of them can be used twice. So this would be 26, P4. Now for this one, I'm going to show you how to do it in your calculator. So we'll do one of each, one with the formula and one with the calculator. So in our calculator, we're going to use the same button that we did before. This will still be our math button. We're still going to arrow over to our probability, but I think it's option 2. Yes. You can see the combination is going to be. Now, you do have to type in this number before you press all those buttons. Okay? So you have to type in the 26, then do this process, then type in the 4, and then hit enter. So the NPR has to be in between the 2 letters. So we clear out everything. So let's type in 26, press our math, arrow over, choose option 2, and then 4. We should get 358,800. You would get the same answer if you did the formula by hand. All right, now in the back we have our combinations. So the combinations are really similar, except the order does not matter. So a selection of items, that should say in which the order does not matter. Now, my example for this one, if you remember, is I put all your names in the hat. Let's do a different one. I picked 3 names. All 3 of you are going to Disney World. Okay? It would be a combination because the order in which you're selected doesn't matter. Now, some students every year overanalyze this. They're like, well, you know, if Sam was picked first, then there's a less likely chance that I'm going to get picked at all. And so, like, the order matters. Like, you don't want to overanalyze it. You just want to think of the 3 people that are selected. Does the first person get anything different than the third person? Now, they all get to go to Disney World no matter which time they're selected. So the order in which they're chosen does not matter. Now, for a combination, the formula is a little bit different. The only difference is that in the denominator, we will have an r factorial up front. Okay? So you can see an example they've done here, 5 factorial over 3 factorial times 5 minus 3 factorial. So you end up with 2 factorials in the denominator. You have to do each of those first, then multiply them together, and then divide everything. Okay? And of course, this is still in your calculator under the math, arrow to probability, and this time we would choose option 3, which is our NCR. Okay, let's do the first one with the formula, and then I'll let you guys do the other ones in your calculator. So we see 10 combination 5. So again, this is telling us that N is 10 and R is 5. So we'll substitute into this formula. You do not need to memorize these formulas. I will give them to you on your quiz, actually like right with the problems. There are a couple that I make you do with the formula. You can check it with your calculator to make sure you have the right answer, but you have to show your work for the formula that you sub in and utilize it. So this should get me 10 factorial over, you cannot just divide these and make it 2 factorial. So please make sure you don't do that. It's not like a fraction 10/5. It's 10 times 9 times 8 all the way down to 1 and so on. Now you can expand the top if you want to. You could make this 10 times 9 times 8 times 7 times 6 times 5 factorial And then you could, if you'd like to, you can divide out one of the 5 factorials. But you're still going to have to type some stuff in your calculator for this one. And then we would divide those numbers. Okay, the next 3, go ahead and try them in your calculator. Make sure that you know where the combination button is to solve. So you'll have to think through, does the order matter? Am I choosing only a selection of items? Is it a permutation or is it a combination? I believe these are all combinations in our notes, but on the homework they will be mixed up, so let's make sure. So disc jockey wants to select 5 songs from a new CD that contains 12 songs. How many 5-song selections are possible? So again, the order for this one would not matter because he's not rating them as like the top song and then second song. Whatever 5 songs he picks are going to get played. They don't get anything special. So the order does not matter, so this would be 12, C5. And then we will punch that into our calculator, and we should get 792 weights. We'll skip the next one because it's kind of the same thing. A reading list, 20 books. How many ways can you choose 7? So that'd be 20 combination 7 and 20 combination 12. Now 11 and 12 we want to make sure we get to because they add a little bit of a more challenging problem. So a pizza menu allows you to select 4 toppings at no extra charge from a list of 9 toppings. 9 possible. So this would be our total, just like our n. You're selecting 4. Now it says, in how many ways can you select 4 or fewer toppings? Now if they just said 4 toppings, it would be 9C4. You'd be done. But because they added in the or fewer, you have to think about if they chose 3, if they chose 2, if they chose 1, or if they chose no toppings. Okay, so you're going to actually do a bunch of these. We're going to do 9C4, 9C3, 9C2, 9C1, and 9C0. And we'll get how many from each of them, and then what do you think we'll do with all of those answers? Add them together. Now you may want to in your calculator, just to save you time, because the first number stays the same. So 9, choose 4, would be 126. You can press, if you recall, the second enter feature recalls what you typed last time. If you press second and enter, and then you can just arrow back and change that to a 3. Just so you don't have to type in all the buttons again. But if you don't like it, bless you. So it makes sense that 9 choose 0 only has one option. If you chose 0 toppings, you'd have a plain cheese pizza. So there's only one. And then all you have to do is add up all of those answers at the end. So just be careful if you are to see or fewer, that you need to include all of the combinations that are fewer than that. Okay, go ahead and try 12, which is very similar. And then I will pull up, you guys can start on the homework while you're here in class. So you do want to make sure that it does give you 3 options, fundamental counting principle, permutations, or combinations for your homework. A couple of them are a little tricky. And also for the ones that say use the formulas and show work, make sure you use the formula and show work. You can use your calculator to check it, but your 10C0. 10C0 should be 1. So when you add that on, it should be the 638. And actually, I'm going to go over one of the questions on your homework because every year a bunch of students struggle with numbers 2 and 3. So if you want to grab a piece of notebook paper, I'll go ahead and go over, since we have time, one of those. So number 2 we'll go over. It says a telephone number contains 10 digits. The first number of the exchange and the first number of the area code cannot be 0. So the area code and the exchange cannot be 0. All of the other numbers can be any digit 0 through 9. How many different telephone numbers can be formed? So the reason that you're not going to use permutations or combinations for this one is that you have different specifications for each number. So you are kind of using the fundamental counting principle, but it's not going to be a straight 10 factorial, because that would be really easy. But we do have a 3-digit area code, a 3-digit exchange, and then our 4 numbers. And we're going to use the fundamental counting principle to figure out how many choices we have for each of those, and then we'll multiply them all together. So they told us that this number and this number cannot be 0. Okay? So it can be any digits 1, 2, 3, 4, 5, 6, 7, 8, or 9. How many is that? 9. Some people will say 8. Okay, so you have 9 choices for this number or this number. Now, all the other numbers can be anything 0 through 9, which would be 10 choices. So you have 10 choices for this number, 10 choices for this number. Okay, another reason you're not doing a permutation or combination is it doesn't say that you're not allowed to repeat the numbers. So you would, if you do a permutation or combination, you're actually eliminating those as you use them. And then all you're going to do is use your fundamental counting principle, which says that you multiply together all of the options. Now, if you don't have to type that all in your calculator separately, you could change it to exponential form, which would be 9 to the 2nd power times 10 to the 8, and then that would be a little bit less to type in instead of all of those numbers. But you would get, I think, 8,100,000,000 phone numbers. And then I'll let you guys figure out the rest of them. Thank you.